Thanks for wanting to listen to me. My talk is about dynamic stuff in Angular 4 in this case, and what I'm trying to do is to bring the dynamic aspect of an application back into to Angular. I started this work on the application that I'm working on 1 year ago when I went to a conference in London, full of excitement to learn Angular 2. Only to find out that they completely ditched support for everything that are dynamic content rendering in Angular 2. So that was a bummer. Back in the days, it was also on beta 17, and then come all the release candidates, which was also a bummer. And finally, a few weeks ago, when Angular 4 came, and I had to upgrade from 2 to 4, I was just like, this is gonna be a nightmare. But no breaking changes, so I'm not sure how they do versioning in Angular. It's really random. Anyways, my name is Morten, and I come from a company called uCommerce, which resides here in Aarhus. We built a commerce platform in the .NET space, which hooks into content management systems like Umbraco and Sitecore. Anyone knows any of those? Some of you do? Okay, great. Yeah, so we deliver our platform to other developers, you guys, and you will, some of you will eventually build web shops using our software. So we're quite far away from the end customer, the retailers that want to create a web shop. So that's a little bit about the background for what I do. The first natural question is why do we want to do this in the first place? Why do we want to build some dynamic stuff that Angular 2 doesn't encourage? They ditched the out-of-the-box support for it, which means that it's not that easy to do. All the underlying components that their own router outlet uses is of course available, so we can do it, but it's a little more uphill to do it. So why do we want to do this in the first place? There's also security issues to take into account, performance issues and stuff like that. To answer this question, I will start out with another. When you build websites for your clients in a normal Angular 2 way, you are close to your retailers or the customers that you have. Maybe they want to do code on cats or dogs or persons or something like that. When you do that, you normally start out with defining a route. Let's say we're talking Angular 2 or Angular JS. It's the same approach. You want to do create, read, update, and delete on random data. You define a route. You define a template. You do some validation. You do web services. You do HTTP requests for those services. And then you repeat again from one with the next type that they need to keep track of. And to me, it's a little bit tedious and a little bit boring to do it like that because we have to do the same thing over and over and over again. And that's not where the fun part of doing Angular applications or doing cool websites for clients lies. So if we can make this a little easier and a little more reusable, then it's we're in a good place. Especially front-end validation, I hate that, and I also suck at it. So I want to solve this once and for all. It's when you do that, you have contact with your clients, and you know exactly what the end result of those pages are going to be. You edit a doc with a name and a color and a size and number of feet and stuff like that, and that's quite easy because you know the end result. But us as platform deliverers, we have no contact with the retailers that eventually will use our software. So we don't know what their requirements are, and especially their workflows, how they manage their data efficiently is not something that we know about. So we cannot solve that in the first place. We can solve some of it, but we cannot solve everything. And we deliver the platform, so that's a problem. So it's essential for us that you have the ability to hook into the software that we do, and modify it so that it fits for the clients that you build websites for. Naturally, a retailer will say, this application looks like crap. It needs to be restyled so it looks similar to what we know. We don't want the left navigation. I want a button up next to the search bar. When I search for something, I want to see stock levels because that's important to me. I want another tab and stuff like that. And if we go ahead and say customers does not need that, well, that's going to bite us in our ass, because it turns out that at some point they do. And then you should have the ability to do that. So that's not so easy in an Angular 2 context when the dynamic part has been scraping away from the top-level APIs that they expose. So to fix that, I've been working on that on and off for the last year. And some of the concepts that I stumbled upon that I felt was important to know about and care about when we do this kind of stuff is these things up here: metadata, routing, dynamic components and reuse. Performance is something that we're going to touch a little bit upon as well. How we manage context in a dynamic world as well. And yeah, there's a lot of fluff and a lot of things that can be more or less complex. So if I can just inspire you to apply one of the things that I will talk about here in this presentation, that you will go home and use tomorrow, then I will look like this. And my inside of my head will look like this. Yeah. So that's it. So let's buckle up and take a look at some of the technical stuff. It all starts with metadata. And for those of you that have worked with content management systems or commerce platforms or anything else, you know about metadata and the ability for you guys to express the data that your end users is going to type into the application. Blog posts, we can define titles, all sorts of crazy stuff. All that starts with metadata, and that is essentially the core of every good content management system. If they don't have that, then it's not that easy to use. Then we would have hard-coded properties like property 1, 2, 3, 4, 5 that we could then type random data into. We need to be able to define the data that we want to use. So the first thing that we came up with was this dynamic metadata model, where on the left side we have an entity that we want to edit. This entity here in itself and all the properties that it has does not describe what it is. It can be a dog, a cat, a person, a car, or anything like that. But up here we have a version of this entity which will actually describe what we're talking about. If we look at this version here, we will know that it is a product. It has a culture, English or Danish or whatever, and an ID. And this is essentially what identifies this piece of data. But what it is in the real world, in a technical point of view, we don't really care about that. We want that to be described in the data that we have, which we have on the right, where we can see that our entity also has a definition attached to it that will then contain a bunch of fields, and eventually the properties that I have down here will tie down to the data that I have over here to the right. How many of you have worked with metadata model like this before? Many of you? Yeah, okay, cool. So you already know how stuff like this works. So this is not that complicated, but it's still the core of being able to create this application here. So the data to the right describes the values that we're editing in the entity to the left. And that is essentially what metadata is. One of the things could be an editor like we see here, string editor. This will then tie down to rendering a text box inside the UI. So it can be something like that. So now that we have a formalized way of interpreting data and describing data, we also have a formalized way that we can edit them, at least if we can make Angular interpret that as well. So the first thing that I thought of was we should have one route to rule them all. And what that ties down to is essentially that my editor in my application is one entity resolver entity editor that will be able to edit every kind of entity in the application. So the route parameters is type, ID, and culture, which is the 3 pieces of information that I need in order to identify my data. The cool thing about that is that now we don't have to define any more routes. Now we can just stick with this one. If we need another custom one, we can of course add it in. But at its core, we should not be able to, or have the requirement or need to do that. And then we can use the resolve properties to load up data. More about that a little later. So now that we have one route and we have one formalized way of describing data, my next thought was that we should also only have one web service to rule them all. And what that means is that my data that I would load up into the application in a few minutes will have an entity, a definition, and then it has this weird layout tree that we see here in our JSON model. And essentially what my application needs to understand is the layout here, which eventually will be transformed into the actual UI. So we have one component here that has a bunch of other data attached to it. So all this data my web service will output this. The cool thing about this and the way that I wanted to do it like this is because that ngAarhus is an old platform. We've existed for almost 10 years, so we have legacy systems that we need to adapt into our Angular 2 application as well. So everything that you were able to do before, you should also be able to do that now. We have a really cool extensibility model on the server. So if we can output that model that we want to extend and modify and all that good stuff, transform it into JSON that our application understands, then we have succeeded. So now I just need to make my Angular application know how to work with this layout object that comes out. So this is my dynamic component that I have been working on. And the 3 lines of code that we see here, or markup, is actually my entire markup inside my entity editor. So this is all that my view is actually outputting in the beginning, nothing else. So now it's up to the JSON data to define how the application is going to look like. So this dynamic component here will then render into to an actual Angular component that has been registered inside the application. So this single component here eventually becomes something like this. It's still in a proof of concept state, so yeah, and I'm a developer, so trying to apply Angular material and still not be that great. But eventually, hopefully it will be a little prettier. So this single line of code becomes to the entire UI. What that means is that if we edit one piece of data, maybe we don't need the 2 tabs, then we can just get rid of it in the JSON structure. So we don't have to tamper with the markup to delete it. If we don't want the bar up in the top to be blue, then we can just swap it out with something else, or we can remove it completely. So everything that we do is configurable on the server side via configuration somehow, which will eventually tie up to having an output inside the UI. So that's the core model for how the application looks like. So every time I change route or route parameters, the entire UI is actually going to be redrawn, so to speak, because the component the root component changes, so the entire UI also changes. And we can see how that performs in a few minutes when we get to that. So we have one root component that defines the entire UI, as I was talking about. But we still have responsibilities as developers. Internally in ngAarhus, when we create the platform, we will expose some components that you can use out of the box, or you can create your own and hook them into the application. So we still, at some point, we still need to identify what is it actually that we're talking about here. So we came up with these 3 properties on the components, which is a selector. The selector just ties down to an actual Angular component. You write a component decorator with the selector on it. That is essentially what that ties down to, like here for the tab view. We have a config property as well, which will be another piece of dynamic data that we can support or choose not to support. We can do both things. So for example, a config property could be a CSS class that we want to tie to the component. It could also be other stuff that makes the out-of-the-box components configurable on its own. Then we have the components attribute as well, or property on the object that defines the children for the component I'm in right now. What that means is that if I have a view container, which you can see in the top, the view container will just take all the child components and render them next to each other, whereas the tab view will render the children as a tab view. So it's up to the UI developer to define the component that we want to support that we eventually can combine together in all sorts of crazy ways. Does this make sense at all to you guys? Yeah, cool. But we also have something like a save button, like you see in the middle there. The save button doesn't really know about children. We don't want to render stuff inside a button necessarily. If we do, that's fine, but if we don't, well, that's fine too. So it's up to ourselves to figure out what kind of config properties do we want to support and how do we deal with children. If we don't deal with them, then don't put children inside that component. Otherwise, things will not just render out. So those are the core properties of the dynamic component that we have. I slowly realized when I was working with this that markup and data is now disconnected from each other, which gives us really cool flexibility in how we want to tailor the application together to the end user. It really means that we can now start to fiddle around with everything. Here we have a property renderer where we can give it a list of properties that we want to render here. Then it will just render in a long list in a form. We can also support lists, say that the customer wants to see the same piece of data in two different places of the route, but in different slices. Well, we can do that because the components here doesn't necessarily bind to something hard-coded, but binds to something via configuration. So if I don't want to see the SKU and allow ordering and long description in my property list, just get rid of it, and then it's not being edited by the end user. It's actually that simple. So now we have a dynamic concept where we can render the entire UI based on the JSON file that I just showed you. We have one entity, which is the entire thing that we're editing. We have a definition with metadata around it. So we need to keep track of all these things here. So it's also a little bit natural to talk about injectables in Angular 2 and 4. We want to make sure that injectables are always singletons. It's great in a client context to have a singleton injectable because that means that we can start to pass state around into the different components. So one component could be a spinner component that shows a spinner if my spinner service says that you should now show a spinner, or something else like that. Another thing is that we have the application context here, which will keep track of what is the current entity that we're editing right now, what is the current definition we're editing right now, and what is the current component that will be showed in my entity editor. So this will be populated into the application context, but not by the application context itself. It should just hold the state. The context will be populated by the resolver that have attached to my route. So the router here will just inject via constructor injection my entity service, my application context, and some other fun stuff. And then when it detects now we're changing route, load the data, and then set the individual properties on the application context, which can then, if we want to do it with observables, fire a callback to those that subscribe for it. Otherwise, you can just grab them directly from the application context. So separating the context and the stuff that populates the context also makes flexibility, because we can also change that from any of the components that we create if we want to. So that's how we populate the context as well. All right. So far we've seen that we have one route to route them all. We have one root component, and we have configurable components. We're talking about a metadata model as well, and context APIs and all these weird things. So why is it that we're trying so hard to be dynamic? As I said, we are a standard platform, and we do not deliver or host the application for the retailers, and we do not create patches for retailers. We need you guys to be able to fix their problems if our application is not good enough. And we know for a fact that all e-commerce projects are not alike, so everyone needs something custom at some point. So without us being able to do this, our platform would suck. Yeah, we need to adapt to existing features as well, where we have an already existing extensibility model that can output how the UI should look. So we just have to adapt it into what we have right now. So this is essentially what we're trying to achieve and why we want to do it. It's also natural to say, why not do it? Why should we choose not to do it? First thing, will it ever perform? We have seen from AngularJS applications that once they become just a little big, the performance and the look and feel of the application can start to become a little slow. The scrolling will be a little clumsy and stuff like that because it's very intensive in the browser. So will we run into the same problems here? Angular 2, they ditched the out-of-the-box support for the same reason. So that's another good argument why not to do it. And yeah, of course, security risks. My opinion on that is that you should just be able to fix security on the server. It's not that easy though, so and I'm sure there's other stuff that I haven't thought about. And the last hot topic in Angular, and why they don't want dynamic content rendering, it will not be able to support ahead of time compilation, which will make the application even faster. Great points. I still want to do it though. Oh, I did not know I had an animation here. It's easy in AngularJS because we can just do ng-include, and inside that we have a rich text editor with a rich text controller, and then everything works. But in Angular, in Angular 2, they swapped everything around and said everything is a component, a class that we export in our TypeScript or normal JavaScript if we want to. And the component defines the markup. They are closely tied together. So it's not that easy because the entire concept of how we do dynamic stuff has drastically changed. But let's take a little bit look at the app structure that makes up the Angular application that I made. It starts with an app module that has one app component that will then bootstrap. This is how the Angular team says you should do it. This is how all the boilerplates works that will give you applications. This is how the CLI will do it. So there's nothing weird going on here. It's still just a normal Angular 4 application like everything else that you would do. We import all the Angular modules that we need, and then we can start to build from here. All components that we do, even though they are dynamically inserted on the page, are still just normal Angular components, so there's nothing complex going on there either. It's just components with a decorator, with a selector and a template, and yeah, that's fine. It's nothing wrong here. Where it becomes a little interesting is the dynamic module. I've separated everything I do into different modules, one of them being the dynamic module here that contains a template builder that eventually will be able to create a piece of markup that corresponds with an HTML markup that Angular 2 will interpret. It's a type builder that can take the input of my JSON file and render a dynamic component based on that. And my dynamic component, which will eventually just be output on the page. So the dynamic component looks like this. It's a normal Angular component. It has a view child annotation so that we can insert our dynamic compiled component as a child on my dynamic component here. And then it uses in constructor injection, it uses the template builder to grab the markup, and then it uses the dynamic type builder by delivering that markup and say, please give me a dynamic component of this. And essentially what it does is that it creates a piece of markup that will then be compiled by Angular to one of the other components that exists. So it just interprets the markup and inserts the component as a child in here. So it's actually not that complex, but getting there was actually quite hard, especially when you were new to everything like TypeScript and all that stuff. So it was a little uphill. Back in the days when you had to do applications, you just had to import a JavaScript file in your markup and then you were coding away. It's a little bit harder now these days, in my opinion at least. So that's the dynamic component. The next thing that I've introduced is a parts module. The parts module only have one responsibility, which is to include everything into the dynamic module. Before we can use the runtime compiler to insert dynamic compiled components, well, our dynamic module needs to know about these. So it needs to import modules, and then it can dynamically compile all the components that are exported by set modules. That's just how Angular works, right? So the only purpose of the parts module is to include everything else. First thing that it includes is the framework module, which contains everything that we do: spinner services, notification services, form context, all the different components that we do, the tab views, the notification components, and all that stuff. All that is embedded inside the framework module that we will expose together with this application as well. Besides the framework module, let's take a look at some of the things that we do here. So this is how Angular says that you should do state in your application as well. We have a notification component that can render a message. Inside the notification area, we inject a notification service, and then all sorts of crazy components can push notifications onto the service that we have to the right, and they will just be shown by the component. So that's sort of the split between how we do stuff in the application. Every time we need to pass a state or do something, we always do constructor injection inside an injectable that we put in. This is also what makes Angular faster than Angular.js, because all the scopes and stuff like that is taken away. So only the right messages will flow in the right direction. We can also do this as observables if we wanted to. So this is just an example of how we inject data into our components. So besides the framework module that contains these things, we have third-party modules, which is modules that you guys will create. These third-party modules here needs to somehow be injected into the parts module that will import it and export it again for the dynamic module, so that you guys can hook in components and injectables and stuff like that as well. You will most likely depend on our framework module to constructor inject a spinner service if you want to show a spinner, or notification service if you want to push that out to the UI, probably via NPM or something like that. And then the entire application will be composed together when we hit F5 in the browser. So that's the structure of the app. So it's the only thing that are a little bit crazy is the dynamic module here. Everything else is just a normal Angular 2 application that most of you know, for those of you that works for that. So that's it. In terms of performance, the first thing that I started to optimize on was the bundle size, because I was developing, and I didn't really care about it. And my app bundle was 3.6 megabytes, which is quite a lot. It's with all markup embedded inside the bundle, though, because we require that in our Webpack bundler. So all the markup is in there as well. So I had to fix that somehow. All the comments and all that stuff were there, so it was just a matter of finding the right tool, which Webpack fortunately had. So I could require this Uglify.js plugin and then put it as part of my build chain. And then the bundle has been optimized for production. And yeah, we can see that then the bundle size came down to 1.3 megabytes, which is still a lot. AOT ahead of time compilation would make that even smaller. But with compression on the server enabled, we are down to 300 kilobytes. And that is for an entire back office that the end users will use to manage their web shop, including markup and all that good stuff. So I think that's a very fortunate and good place to be in. Now we just have to figure out what about the performance when we actually start to browse around on it. AOT is not supported, as I said. There's nothing to ahead of time compile in a dynamic world. But actually it should be supported. There's still a bunch of stuff that we can ahead of time compile, but the ahead of time compiler plugin simply fails because it detects that I have a runtime compiler injected in my application, and it says, well, we cannot do that because you're using the runtime compiler, so screw you. So I have to fix that. And I know there's the fix for it somehow, I just need to figure out how. Yeah. So while we're waiting for ahead of time compilations, it's always easy to just put a spinner on the side, and then that will give us perceived performance because that means that we're doing something heavy duty. Of course, we have to pre-compile during startup so that we don't have to compile all the time, which will make a little more clumsy user experience for the user. We need to cache all the components as well, of course, in order to only compile them once. There's no need to do it multiple times. And then we'll see now, I'll swap over to the application, that runtime compilation is actually not that slow. So I have to close down the PowerPoint, otherwise the video will not see my browser, apparently. Yeah, I'm using a Windows platform on my Mac. I know I'm a fool, but I code in .NET, so I need it, and I like Macs. So this is the application. This is the front page. Let's try to do F5 just to see what happens. Did you notice the little spinner in the beginning? Yeah, it was gone really fast, right? That's actually 25 components that has been compiled now, and that's all the different components that I have in right there now. So the 1 second wait we had there was what we could save with the ahead of time compilation. In terms of not doing runtime compilation, but there's still a lot of tree shaking that ahead of time can make the bundle a little smaller. So this is the front page. Let's try to navigate through. Again, every time I change route, the entire component tree changes, which means that the entire UI changes as well. And yeah, right now it's not that slow. I think the performance here is decent. And I have created stress test components that will put a lot of different dynamic components in there, but the performance seems to be quite stable. After upgrading to version 4, at least, I could actually feel the application being much faster just by upgrading there. So I think the Angular team has done a very good job with the performance already in there, which is quite nice. Let's see how we can change the UI real quick. This is just a small little demo here. Let's get this over here. Notice that we are on product 105 in English. I will go to my data, Right now, my data is not attached to a server. It's just JSON files, but that mimics the web service calls. Let's go to ENUS. And here we can see this is essentially what the server is going to output, all the components and all the definition fields on the definition and the entity itself with all the data on it. Sure, I just need to figure out how in .NET. Oh, that was wrong. I can only, did that make it bigger? Yeah. Okay, fine. So let's go down to the layout. Let's see. Let's remove something random here. View container, sidebar, category, main container. That should be a save button somewhere. Let's get rid of that. Go back to the UI. And yes, something with my light server makes it not work right now, so I have to go back in there. Let's search for a product, black. There we go. Okay, that was actually the wrong one that I edited. Yeah, doing live demos and editing JSON is not that fun. Let's see, 155 instead. Sorry about that. In the right language, of course, English. Let's search for save button this time. There we go. Get rid of that. Go back and back and now the save button is gone. So yeah, that is what we want to achieve with this. We want the ability to let the server decide how the UI is going to look like, and then we want to let Angular interpret how it should look like, and actually show the data on the screen. Even though that we do dynamic stuff here, we still have support for things like validation and unsafe changes, because we can have the form tell us that we have dirty data. So even though that we insert dynamic data, the form will still detect that we have a change and say, "Are you sure you want to discard that?" And yes, we do. And we want to go back again, and we want to change language, and the save button is back. And is there validation on any of these? No. Validation is also something that are part of the definition field. How should this field be validated? And none of it says that there is validation here now, so yeah, I can show that right now. I don't know where we have something. Maybe this one, please? No. Okay, never mind. That's it. Do you have any questions? Yeah?
So there's a back office for a web shop that doesn't have to depend on Braco or Sitecore?
Yes. Yes. We want to be what we call CMS agnostic. We don't want to do any dependencies directly on the CMS because we have to support many. So in this case, the application has to live on its own, and we have to use our own back office. This will eventually be integrated into both Sitecore and Umbraco, and we're going to change the styling so that it resembles the core application. So those that uses it on a daily basis and doesn't feel like they change system when they go from Sitecore or Umbraco into our system. That's the model that we're using right now to do it. Yeah. Anything else? No? Okay. Thanks for listening.